If you don't know what a buffer overflow is, you are probably asking yourself, what is a buffer? And why would it overflow? If you do know what a buffer overflow is, you might be asking yourself, an entire Pluralsight course on buffer overflows? Really? Yes, really. If you are studying for any sort of IT or ethical hacking certification, or learning a skill set like computer programming or penetration testing, understanding what buffer overflows are, why they occur, what they can do, how to find them, how to detect them, and how to prevent them are all things you should know. So for me to present this knowledge to you, yes, I needed to make an entire Pluralsight course on buffer overflows. I have written this course with the idea that you may understand very little or nothing at all about how a computer software program is designed or what's going on inside of a program running on a computer. This is, after all, an IT course and not a programming course. However, buffer overflows is a difficult topic to learn if you don't know some of the basics of how computer programs are created and what's going on inside of them when they are running. I will therefore be giving you just enough information necessary to understand buffer overflows without trying to make you into a computer scientist. However, if you do have some computer programming knowledge and skills, you will find them useful for understanding the material in this course. The term buffer overflow comes from computer programming. It basically describes a condition inside of a running program in which the data is being written into a temporary storage area called a buffer. And for some reason, some of this data is written outside of the buffer. When this happens, you guessed it, the data is said to have overflowed the buffer. Computer scientists will say that the data overran the memory boundaries of the buffer. So buffer overflows are also referred to as buffer overruns. Buffers are areas of a computer's memory that are used for temporarily holding data in a running computer program. When you are working on a file in an editing program, typing your username and password into text fields, or viewing a Pluralsight course in a web browser or in an app on your phone, you are seeing data that is being stored in a memory buffer. Buffers may exist anywhere from just a few milliseconds to the entire lifetime of a program. A typical program can use hundreds or thousands of buffers. Memory buffers are therefore a fundamental component of every computer program that we use. Buffers have existed and have been overflowing with data for as long as there have been computers with random access memory. Buffers overflow for the same reasons you would overflow a drinking glass with water. Maybe you didn't realize the size of the glass or how much water was already in it. Maybe when you poured, you missed the glass entirely. The same thing can happen when writing data into memory buffers. If you keep filling a memory buffer with data and don't watch where you are writing that data to, your write operation will exceed the memory limits of the buffer. But instead of getting water all over your table, you get a memory fault in your running computer program. All programs should contain logic to detect and prevent possible buffer overflow conditions, but unfortunately, that is a detail in software development that is sometimes overlooked. So what happens when a buffer overflows? A buffer overflowing with data is not a guarantee that anything bad will happen to the running program, or to the computer running the program, or to any information accessible by the program or computer. It is far more likely that a buffer overflow condition will cause a running program to become unstable or crash, possibly create or return bad data, or even run other programs in violation of the computer security policy. It is also possible a buffer overflow will have no bad effect on the program at all. In fact, as common as buffer overflow problems are in computer programs, they are difficult to find and even more difficult for an attacker to exploit for some nefarious purpose. Nevertheless, there have been some spectacular examples of malicious software that have made great use of buffer overflow vulnerabilities in both programs and operating systems. It may seem strange to think that you can do anything interesting, much less useful, with a flaw in a computer program. Buffer overflows can cause a running program to perform some other operation that the software's designers did not intend, such as unexpectedly running another program, giving an attacker command and control of a computer and a way into the network, and possibly access to other systems on the network. Buffer overflows can also provide access that leads to the theft of information or overwriting data in memory, causing data to be destroyed or replaced by other data. This data corruption may cause a program to return incorrect data or alter how the program runs. Buffer overflows are also a convenient way to cause a program or operating system to become unstable in its operation and possibly crash, resulting in a successful denial of service attack. So what can you possibly do with a buffer overflow condition? Seems like there's a lot, really. So how do you keep the many necessary buffers in a running program from being overflowed? You basically have two options. Reactive: detect the buffer overflows as they happen and try to minimize their impact on the running program. And proactive: prevent the buffer overflow conditions from occurring in the first place. Obviously, we want the proactive solution whenever and wherever possible. But so far, in the entire history of computer programming, we haven't been able to eliminate buffer overflows 100%. So both proactive and reactive options are definitely needed. Keeping buffer overflow conditions from occurring is the responsibility of the programmers who wrote and maintain the computer programs. Programmers must proactively write code necessary to keep buffer overflow conditions from occurring and reactively fix buffer overflow conditions in their code when they are found. It is also the responsibility of the system administrators who maintain our computer systems. System administrators must proactively use hardware, software, and configuration settings that make buffer overflows very unlikely to occur, and reactively use system security software to detect when buffer overflows have occurred and mitigate their possible harmful impact.